call the stone by its name this time. So on that note, I would like to reiterate our thanks for the support of Wallonia-Brussels Architecture, as well as the AA public program, without which the event wouldn't have been made possible. Thanks also to the AV team and Ben Hibbotson behind the camera there. Thank you. I am Audeline Dullière. I had the chance to join force with Juliette on the placeholder installation that she briefly introduced this morning. And I have been co-teaching a diploma unit at the AA in collaboration with James Westcott and under the auspice of Rotor, which brief develops a focus on material reuse and more broadly questions our relationship with our building stock. Today, the unit's community counts 4 generations of young graduates that have been exposed to question of material procurement, or management of resource and its impact on the labor market. And together with Rotor's members, we like to maintain a dialogue and support each other, research and project through communing or reading reference, experience and resource. This morning, we have learned about the embedded value of stone, its tectonic and cultural significance as part of our cities and structural capabilities, as well as the century-long tradition of stone, maybe archaism, should I say, of stones as Spolias, and the remarkable ingenuity, thanks to Simon, of Roman builder in reusing stone fragments. We possibly took a detour through the underground geological layer where everything starts. Now we will explore the reality on the ground and the landscape of current practice, possibly celebrating the ingenuity of today's experts. Today, it is recognized that approximately 1% of the material is being recirculated within the building industry, which means it is being reused and valorized following a first application. And this 1% reuse ratio is also most probably the case for stone. What happens to the rest, the 99%, is crushed into aggregates, which we like to call recycling. This is, in many cases, an euphemism for downcycling in the best case scenario, and a large-scale destruction of value in the worst. This 1% has probably been maintained and pursued through diligent preservation work, such as the work that Robert Greer has been doing since 3 decades with the company Payne Stonework and Restoration, in dismantling and rebuilding entire Ashlars masonry facade in London, such as the Royal Opera House and the Royal Albert Hall. Robert is replicating a multi-century-long expertise and technique, going through the laborious task of recording and numbering every element of architectural significance prior to dismantling. Simultaneously, he is constantly looking at ways to improve the practice in testing technology too. For example, is the surveying of the building fabric. He is also keen to strengthen the environmental policy while transmitting the tradition to skilled craftsmen. Robert has been an instrumental ally in advising us and for the execution of the placeholder project at the V&A, since Pay provided support in kind to reuse the stones that they had dismantled years ago. Robert is working in majority with heritage projects, which means that it is understood that the stone building components have an intrinsic value, which means that it is worth investing, and the project envelope budget will account for the care required in the art of recording, dismantling, palletizing, storing, transporting, and reinstating. We will then understand what it takes to go beyond this 1%, especially the legwork for building components which intrinsic value hasn't been recognized yet, and for which no budget allocation has been assigned for its salvage. No dismantling time has been accounted for the project management calendar. To salvage this component of less significant value and reintegrate them in design proposal, it takes a lot of goodwill, ingenuity, strategy, and elegance. It takes perseverance, conviction, lots of tries, some error to move the line one project after another. These are the projects that Lionel will present you through the work of Rotor. Lionel de Vlieger trained as an architect and engineer in Ghent and Rome, while setting up practice as an independent marble craftsman contractor. Lionel co-founded Rotor in 2005, a research and consultancy group established in Brussels promoting building material reuse and circular strategies. Within Rotor, Lionel managed design, research, exhibition, and consultancy projects. He obtained his PhD in architectural history and theory from Ghent University, where he now teaches as associate professor in cultural and material history of architectural practice. Making material reuse possible calls for allies that understand the stake and associated challenge. This requires a common vision and a willingness to take risk, since operations today are carried outside conventional framework. To move the lines, you need a three musketeers approach, where at least three key stakeholders in a project development decide to take the leap together, sharing a measured risk and allowing space for experimentation and new protocols. This way, they create precedent, set up exemplary project, and contribute to a culture shift and a new way to design and approach our building stock. The respondents to this panel, Adam and Valerie, are undeniable allies to facilitate the reuse of material in their respective position of material reseller in London, maybe a simplified definition, I have to say, and developer in Brussels. They are musketeers. Adam started salvaging and collecting material with Maria's Peak since the 90s with their company Retrivius. They continue to champion the reuse of salvage material alongside a broad approach to sustainability, turning respectfully reused material to distinctive contemporary ends. Adam's warehouse provides a refuge for an ever-changing stock, ranging from topical hardwood architectural elements, eye-catching one-off, rugs, and lighting. When the abstract concept of urban mining seems to represent flawless operation, the reality is more complicated, and Adam goes to the front, salvaging batches of materials from London's buildings doomed for demolition, operating within the often too narrow, or rather inexistent, time window that will be left open for dismantling work. Valerie, as client representative and developer, and with her background of management, engineer, architect, and conservation architect, is at a strategic position where decision can be taken to change the way we see construction and development. She aims to define and settle clear sustainability goals on each project. For example, in leading in collaboration with Rotor, a spectacular project of stone reuse where 140 stones of Belgian blue limestone have been salvaged from a modernist building and are being reconditioned for in situ reuse in the new development project. This required surgical precision and the sophisticated choreography of hydraulic jaws to dismantle and salvage these modern building components, which you might see in some extract in the documentary that we played at the start of the day. Without further ado, I would like to invite Robert to present the work of stonework and restoration. Lionel will then follow remotely, and we will continue the discussion with Adam and Valerie. Valerie will also update us on the very last application of stone reuse in situ for the project multi. And so we will conclude with a Q&A session where we also invite the contribution of the remote audience. Question posted in the chat will be relayed to the panel. Thank you.
Good afternoon, everyone. I'd like to spend the next 15 minutes or so providing an insight into the challenges and complexities of repurposing masonry on some of the ambitious building projects we've completed over the past 25 years and how the approach has evolved to assist the design team in the project. Before we look at those, I thought I'd just discuss this fantastic word, anastylosis. Anastylosis is an archaeological term that refers to the reconstructing ruined buildings and monuments. And the key to anastylosis is that as far as is possible, the original architectural elements and materials are used to reassemble the structure. Completing an accurate record of the original construction, leaving nothing to conjecture, is really at the heart of this. And this was captured by Oikos in their Venice Charter of 1964. where they stated that the structure's original condition must be scientifically confirmed, each recovered component's proper placement must be determined, and replacement materials that are used must be limited to those that are necessary for stability. And whilst this charter was really focused at the conservation of buildings and trying to retain as much of the original fabric, the idea that you shouldn't leave anything to conjecture or guessing is at the heart of what we have to do when we're dismantling a building. And part of this next 15 minutes, we're going to see how that whole process has evolved from rudimentary drawings in the 1990s through to using modern technology today. The first great project after the development of the Venice Charter was the repositioning of the monuments that were sat within the floodplains of the Aswan High Dam. And in the late 1960s, it was decided to dismantle and re-erect a lot of these monuments, putting them up onto higher ground. And this was the quality of the information that they started with. But when you look at the scale of the buildings they were dealing with, you could see the challenge that they were posed. And it was interesting to see Simon actually made reference to this in this morning's lecture with the Temple of Philae, which was one of the buildings that was moved. Moving on 30 years, this is the first project that I got involved in about 1997. And this is 68 King William Street, which is on the north side of London Bridge. It's not a listed building, but the client decided to dismantle and rebuild the top 5 floors of the building to help support the repurposing of this building. And at the same time, we stretched the height of the area highlighted in yellow by 3 meters to increase the floor height of the floors at the upper levels. It's fair to say that back in the 1990s, the reason for dismantling and rebuilding buildings was really focused on offering it to try and achieve planning, whereas now it's being offered to try and provide a sustainable material. There's been a real sea change in the reasons why developers are offering the dismantle and rebuild of buildings, and we've seen that certainly increase over the last 5 years. Sorry, just going back to this building, when we actually surveyed this building, we surveyed it from the scaffold and we dismantled it the next day. So it was a very frenetic process. It was draw and go. There was no real time to assess what we were doing, to understand what the impact was of what we discovered. We just had to capture it and take it off the job. Moving on to 12 years, we went to this building in about 2009. Which was a monolithic facade. It's on Piccadilly. It was part of a grand scheme for the Crown Estate. And here we had a little bit more time to carefully dismantle the building. So the records were a bit clearer. But what we had to contend with was the problems of the original construction. And again, we only discovered these problems as we started to dismantle. We found that there was embedded steelwork which had fractured stones. And on the image on the right, you can see the lovely fracture through the top of the cornice block, which meant that it questioned how we're going to use that in the rebuild. All of the stones were catalogued, palletized, taken down to ground with spider cranes. And then they were placed onto the vehicles and taken away. The stock bricks were salvaged and placed in a skip, and then they were taken away separately and palletized and cleaned up on off-site where they had more space. When we dismantle buildings, our normal attrition rate is maybe 2% of the stones that we remove. On that project, there was about 3,000 stones, and the stones that we did actually break or damage were either damaged originally or it's something we felt was best to damage so that we could salvage a stone which was of more architectural or sort of financial significance. So there were the odd sacrificial stone, but overall we rarely damage any stones on a project. Then everything goes to our warehouse where it gets stored. Storage is a real challenge on projects. It is a very high cost, depending how long it is between dismantle and rebuild. And this has proven to be quite a problem throughout the project. Some clients get smitten by the idea of someone offering a field to place all their pallets of stone in for free. And then we have to go along 2 years later and put all those stones onto new pallets because the original ones are rotten. And therefore it costs them the same amount to have actually stored it properly in the first place. With the rebuild, at that time, it was rebuilt as a monolithic masonry construction. And that was the approach that they had to commit to before the design had really got into earnest, because they didn't have very comprehensive details of the original construction. And we could see the scale of the depth of the wall and the monolithic nature of it. All the stones needed to be grouted. And it was a constant installation of heavy masonry, each stone weighing over 1/4 of a ton. What we have here is the original building on the left and the reconstructed building on the right. Portland limestone, we're very lucky. It's a stone which is soluble, so it normally cleans up really well with just cold water, and with a specialist person who's actually doing it for them. On the lower levels of this building, it was actually clad, so it's monolithic from second floor up. And the lower floors, we clad that with Portland to overcome the shocking 1980s shot front that was there before. This next project, which was noted this morning, is the Aston Wedge screen, which was built in 1909 as a clever architectural intervention to hide the museum's Victorian boilers. The screen originally featured a solid stone wall facing Exhibition Road with a crested central arch and topped by a graceful colonnade that allowed passers-by a few discreet glimpses of what was behind. In 2013, as work began on realising Amanda Levette's design for a new courtyard and entrance, we removed the Grade 1 listed Aston Wedge screen to protect it and allow the work behind to go ahead. Compromising of 1,375 stones, the screen was in safe storage for 3 years. Then at the end of 2016, we started on reassembling this historic structure, incorporating changes to make the screen more engaging to the public. So here we have just a simple record drawing of the screen before we dismantled, and then the proposed reconstruction with the post-tension columns, which are double-story columns. Dismantling each of the stones was extremely difficult. And this was down to the quality of the grout that they'd used in the joggle joints, which comprised of very hard flint and a very strong cement mortar mix. The masons used a traditional plug and feather technique, which is normally used in the quarry to split blocks of stone in half. And they drilled the holes into the joints of the stone, put the plugs and feathers in, and tried to drive the stones apart. The problem was, because the grouts were stronger than the stones, sometimes it caused damage to the stones. Therefore, we had to think of a different way, and we used a ring saw, which allowed us to get a cut depth of about 200 millimeters. So we cut every joint first down to a depth of 200 millimeters, and then once we'd completed that exercise, we then used the plug and feathers. So here we see a simple timeline of the process: cleaning the beds, cutting the joints, installing the plug and feathers, and then breaking the bond of the stones to push them apart. It was a lot harder than we expected, and it took a lot of time, but there was a need to do it correctly so that the stones could retain as much of their original edges and condition as possible. Once we'd split the stones apart, we then used another traditional method of masonry, which is called a Lewis pin, which is designed to open once you apply load to it. So we drilled the hole, installed the pin, then lifted the stone enough so we could put a conventional strap underneath so we could lift it more safely after that. The stones were weighing over 1.5 ton on the grand cornice. And these were being moved around with skilled masons, but also with specialist lifting equipment. So here we have the image of the screen before we started, and here's the screen on completion, providing the more engaging entrance to the side of the Victorian Albert. 1-3 Grosvenor Square was the former Canadian Embassy in central London, and it was sold off as a private development. And we were tasked with dismantling the building, placing it into storage, and then reconstructing the facade as a new face to the new structure behind. The client had two main requirements for us. One was to increase the height of the building by 2 meters, and the second was to provide no visible movement joints. So we had to consider how we were going to achieve this task. Stretching the height was relatively easy because we found there were certain architectural details where we could add additional courses to push the height of the building. The blue area is actually a new elevation that we installed. With the movement joints, we looked at the use of hydraulic lime mortars and how we could use those to extend the distance between movement joints beyond the perceived code. And we provided them with a facade which has discrete joints which are hidden behind the way that we connected two elements of the facade together. Again, we had the usual task of trying to survey the building, catalogue the building, and dismantle the building in a very short time. Every stone is provided with a unique reference number. Here we have window head S107, which we thought was just one stone, and when we got up there, we found it was two stones. And these are the things that we constantly had to deal with on a day-by-day basis. Again, every stone's catalogued, every stone is placed on a pallet, and that pallet was placed on a hard standing in East London. Record drawings were created, and as part of this process, before we started, we also used GPR, ground penetrating radar, that allowed us to assess what the depth of each stone was. We've got a way of recognizing the difference in the flutter of the GPR scanner, so we know where the density is changing from a solid material like the stone to the less dense material like brickwork behind. We then looked at some of the lovely old 1920s construction books that we have in our library, and we found details similar to what we thought was being used at the time. We looked at the bricks and the condition of the bricks and the types of mortars that would allow us to replicate the original mortars to the best of our abilities. And we completed trials, and this area at the lower level was actually dismantled and rebuilt with new bricks and new pointing to mimic the uncleaned element at the upper level. Just quickly on the bricks, one of the problems we find on this project and most projects is it's very hard to demonstrate the suitability of a brick in a new use. We can't test it because things like frost-resistant testing, we'd have to test virtually all the bricks to satisfy that they actually fit for purpose. So we had to go through a process of selecting particular bricks based on certain criteria. And we found enough bricks from the dismantling process to reface the Grosvenor Square elevation. And then we found a new brick that was a very close match that allowed us to clad the rest of the building. With the facade itself, it was a complex challenge because we had a facade of brickwork and stonework, which we weren't allowed to have any movement joints in. And then we had a concrete frame behind with post-tension slabs. So the concrete frame through elastic creep is going to shrink by about 1 millimeter per meter over 50 years. And you've got the deflection of the post-tension floor slabs. Then attaching to that, you're applying a monolithic facade. So we installed a stainless steel frame within the cavity wall construction that was able to articulate the different movement criteria of the two structures. So here we see the red box with the black core. That is a stainless steel box section that was attached to the concrete frame with sliding joints, as you can see in the top right of the image. So that provided us with the ability to control the movement of both of the structures. Movement joints were modeled in 3D before we started to make sure that what we thought was going to happen when they expanded and contracted wasn't going to impact upon the integrity of the building. And then what we have here is the section through the facade and 3 images of the building in its original form, completed form. Now this moves us on to 2022, which is where we are now. And this is a building that we've been looking at for the last 4 months. This is in central London. It's a 7-story building. It's built about 1915, and it's got a few inherent defects that need to be addressed. So we've been tasked with the challenge of dismantling the facades, reducing the thickness of the facades, and then rebuilding the building attached to a new concrete frame that will be constructed behind. And this is where we've started to see a real benefit in the use of modern technology. The first thing we've done is completed a point cloud survey of the building. And a point cloud, I suppose, has come out of the whole BIM process. And this has evolved as a 3D virtual model development to facilitate successful on-site execution of new build projects. And BIM has really been at the forefront of that. The challenge we have is that we're working on a building where we really need to know how the building was built before we start the project. And 3D laser scanning has helped us to do that. With the security requirements for the building, internal access was not possible. So all of our survey works were completed externally using drones and mutes over a 2-month period. At the moment, we have completed the models of the external facade. The model itself, and as we can see here, this is a close-up of the point cloud survey, and we could just see the little dots that form the register points for the facade. With regards to tolerance, the point cloud survey is normally about plus or minus 2 millimeters. When we're trying to work out which dots are actually the edge of the stone and which are just a part of the face of the stone, we've got a tolerance about plus or minus 4 millimeters. So overall, we're creating a solid, strong record of the facade to within 6 millimeters of its correct size. And if you go back to what we were looking at 25 years ago, when we were just sort of drawing it as we got to it, it's been a real sea change for us in how we approach the dismantling of buildings. This is a scan from a couple of years ago before drones were available to us. And you can see there's a few black shadows above the sills and above the cornices in the projecting areas, because the conventional laser scanner sat on a tripod at pavement level is unable to see those areas. With the advent of drone 4K imagery, we're able to get a fantastic record of the building. And what we've been able to do is to combine that with a laser scanner attached to the drone. So we're now getting a full 3D model of the building before we start. The drone survey provides us with a visual record in a series of vertical drops that allows us to assess the condition of the masonry. And this also goes to the architect to advise them of what parts of the design actually worked and didn't work with the original construction. So we can help influence how they look at the remodeling and what they may need to change. And a classic problem with buildings of this nature is how they address waterproofing to the sky surface of the projecting details. So we're looking at ways of reversing the fall to these cornices. Here we can see a rather crude repair to an original detail, which is very poor. So we're going to look at how we change the leadwork details on the building. As with the previous project, we completed a GPR scanning survey of the facade. So we understand what the depth is of every single stone on the building. And we've mapped that onto the elevation drawing. So we know exactly where the face is, where the back face is. So we can start to look at how we reduce the thickness of the wall to create the optimum thickness of masonry to allow them to put an inner wall line in, which is on one consistent line. This has then been imported into our 3D model. And what we can achieve from this is we can actually work out where the window line is for each window. So we can work out where the back face of the original stone is. We can work out where the front face of the original window is. And we can start to have that conversation about where the column line should be, where the slab edge should be, where the grey back that we're attaching all the masonry should be. And we can start to build up a more detailed understanding of what they can do for the repurposing of the stonework. And this is at stage 2 or stage 3 in the project, and not at stage 5, where we used to be starting to have these discovery discussions. With our models, this is an exploded version of the previous screen. Every one of our stones is drawn individually. There are 5,500 individual stones drawn on this building. So we can understand what the impact will be of any movement, of any change in any part of the structure or detail that the client requires. Here's a couple of screen grabs of the ground floor. So what we were trying to understand was what would happen if we tried to stretch the ground floor by a course, and how that would impact upon the entasis of the circular columns which are against the windows. It was proven that there was not an opportunity to do anything with this because it would have been such an adverse effect on the masonry. So they moved on to look at another solution to the challenge they had. Whilst this exploded view shows the kit of parts that we're going to be carefully dismantling, we could have just drawn this as a flat plane, just as a simple flat element of stonework, but we recognized the benefit of modeling and capturing every single piece of stone as its own individual model. And we've started to look at the next phase of the process, which is the dismantling, and how we can improve the process of dismantling. And what we found is that the usual error is the human error of recording the information of each stone as we remove it off the project. So we've started the development of our own app. And with our app, we're going to apply an RFID tag onto every stone. In the left, you can just see that little screw of a black tag that we're going to attach to every stone. And when you scan that app, that RFID tag with your iPhone or Android, depending what's your preference, it will actually provide you a link to a website. And on that website, we're able to catalog the original size of the stone, the palette reference for the stone, what we need to do to that stone to allow us to incorporate it into the new works. And the other thing that it will allow us to do is to understand what our productivity is in real time. Because it goes straight to the cloud as soon as you scan it, we'll know exactly what day it was removed, who removed it, and also as we come back to site, who installed it, and we get a full understanding of the quality process. This is a final picture in front of the previous job, which was 1 to 3 Grosvenor Square. This is the team that was required to deliver a project of this scale. And this new project is twice the size, it's got twice the challenges, but we aim to be doing it with the same number of people managing the process because of the ability to use the drone surveys, to use the RFID tags to allow us to sort of simplify and use technology to support our business. Thank you.
Yes, so now I would like to invite Lionel to join us remotely, if he's in the room.
All right, can you see my screen?
Absolutely.
Okay, perfect. All right, so I will first start with introducing Rotor very quickly for those who are not yet familiar with the organization. So as Odeline mentioned, Rotor was started in 2005, and initially we were looking a lot at, let's say, the leftovers of industrial production in general, looking at amazing or strange objects like this one, which is a color transition from a bin liner producer. It was a question of trying to find new potential uses for these materials, but also to look at the kind of culture that is embedded in these products. But then very quickly our attention shifted towards, let's say, within the large field of the industry. We started to focus on construction industry because we realized that in the context of the construction industry, the amount of resource waste was so staggering that it seemed to us that it would be quite simple to make a little bit of a difference. And we were shocked by the way in which the practice of downcycling buildings by crushing the inert fraction of it into aggregate was so widespread. We were also shocked by the fact that some public authorities like the Belgian or the Flemish government were even proud of that practice, which for us boils down to the systematic destruction of value and its reduction to something that is utterly meaningless and deprived of any kind of use value or whatever other value you might imagine. Now, studying the whole, let's say, sector of building and demolition waste production, we gradually also looked at the numbers and were pretty much amazed by the fact that the situation was not improving. On the contrary, what you're looking at here are the numbers for Belgium, the EU at large, but Belgium is specifically, I'm looking here. So you see that in the period between 2004 and 2016, you have an increase of the amount of building and demolition waste that is produced, that is almost boils down to a doubling. So we go from 11 million tons to almost 20 million tons in that pretty short time span. Now, it's a question that we've always asked, why is this happening? Why do we have that increase? And let's say there are probably many elements of an answer there. But one particular culprit that we would point to is the phenomenon of architectural obsolescence. So the fact that we have buildings of large size, even mega size in some cases, that are being demolished after increasingly short lifespans, such as this building, which was barely 30 years old when it was raised in 2019, a building from the Flemish government, or this building, which fate hasn't been decided yet, but it's the European Parliament building in Brussels, which is also a little more than 25 years old and might be raised completely as well. So it's another topic, but it shows that we are dealing with let's say important cultural question marks. Now, Rotor today is let's say this is the way we present ourselves, is like a table with 4 legs. Part of the organization is dealing with interior design projects. There's a lot of work around design assistance. I will come back to it. There's a cultural dissemination part of the work of Rotor, producing exhibitions, conferences, teaching. There is research, and then there's a 5th leg that has been added, let's say already 5 to 6 years ago, which is Rotor DC, which is now a spin-off company that is active in the dismantling, the refurbishing, and the resale of building elements. Today, formally, you have on the one side Rotor, which is a non-profit organization still, ever since it was founded. And then you have Rotor DC, the spin-off, which is a more commercial company, but it is organized as a cooperative company. This is already a picture from 4 years ago. So we had a big team back then. It's slightly bigger even ever since. The picture was taken on our premises in Anderlecht, on a location not so far from the Brussels South railway station, so very close to the city center. It's a location that we're using temporary. We will have to leave there soon, but it allowed us to use, let's say, a space of about 5,000 square meters, half of it outside, outdoors, and half of it indoors. Here you see a few images of the warehouses and the showroom. Now, what has Rotor been doing? I already gave you that overview. I won't go over it all. That's not the purpose of this talk, but an important portion of what we do is providing advice on how to manage, let's say, so advice to public authorities on how to tackle the whole issue of building and demolition waste, and to push these authorities in the direction of more virtuous practices. And in many cases, this means pointing back at what was being done in the past, which was always better than what is being done today, and such as the practice of selling buildings that need to be demolished instead of just asking a contractor to break it down. In many cases, the value of the building materials of structures such as this one, a 15th century city gate, the value of the building materials was far higher than the cost of dismantling it. So you had the whole procedure that was existing to take care of it. It was a form of public procurement for dismantling. We also give advice on what could be done in terms of contemporary policy through books such as this one you might be familiar with. The sketches showing one of the ideas that is, let's say, that is a very simple one, which would be to force anyone who's taking down a building to put 5% of the value of the volume of what is being dismantled aside for refurbishment and resale. Now, we've also done a huge work of documenting in Belgium those companies that are already active in the refurbishment of second-hand building materials. That is the project Opalis. I will come back on it later. It's a project that started around Brussels, grew over the territory of Belgium, and now is expanding towards France, the Netherlands, and we're also looking at the UK in collaboration with our partner Salvo in the UK. Obviously, we hope to expand this project even further in Europe, but it's going to take some time. The major recent expansion happened in the context of this project, which is a European Interreg project, FCRBE. If you type that in, you will find the website of the project with lots of documentation materials and also policy advice materials. So the project has entered the second phase now, but an awful amount of very useful deliverables have come to surface. So I definitely recommend you to go and see there. On the left-hand side, you will see all the partners involved in this project. Obviously, this was the purpose of projects like that is to look at that gigantic network of operators which are engaged in the tantalizingly complex work of refurbishing existing building materials. It's in the continuity of the notion of urban mining, of course, even if we tend to be a bit, let's say, skeptical sometimes about that notion of urban mining. But any case, most often we enthusiastically embrace it as well when it's useful. Now, to get back to the practice on the field, this is a project that I wanted to show you because it has been like the project that kickstarted Rotary DC into existence. It was a project that started in 2014. The building you're looking at is no longer there today. This was the seat of the most important Belgian bank, which has been taken over by the French, is now the BNP Paribas Fortis Bank. This building from the late 60s, built early 70s, is a brutalist design. It wasn't really loved so much, but everybody was agreeing on the fact that the interiors of the bank building were amazingly well designed and also realized in very precious materials. I don't know if you can see it, but have a look at the octagon flooring in this building, which is made out of the same granite that is also used for the walls here. You will see it later on in this presentation. So we went to that building and we, on invitation of Docomomo Belgium, and we were invited to extract as much as possible. The first motivation was a heritage motivation because of the value of these interiors, but obviously for us, the environmental dimension also played a role. So here you see how we, as part of the extraction process, we took out these wall elements in granite. These were cleaned on the spot, on site, palletized, and then brought to our warehouses. One of the other elements that we extracted from there were these ceiling elements of the ground floor of the building, which was the public part of the building. It's, let's say, a design that has been used by other famed architects, but very much loved by Jules Wabs, the designer of these interiors. The ceiling is filtering the neon light that is coming from the top, but also hiding all the techniques away, like the sprinklers, etc. We developed a technique to dismantle them, and obviously the system is flat pack prone. So we were able to dismantle like hundreds and hundreds of square meters of this ceiling. Afterwards, the product was put on the website of Rotary DC and sold to a variety of partners. There must be like 20, 30 different locations in which you can spot this particularly ceiling element. But I will only give you one example, which is a project that, a design project from ourselves, from Rotor. This is the lobby of a social housing company in a small town, eastern Belgium, called Westerlo, where we used a portion of that ceiling light system to install a light above the counter of this interior. The tree you see on the wall is a marquetry of melamine, also from the 1970s, also from the bank building, but by another designer. Most of what you see in these images from that social housing company is second-hand in terms of the finishes, but we try to make it look as non-second-hand as possible, as welcoming and homey as possible, with a kind of a Japanese hint as well there. But I wanted to take you to the backside of this renovation project, where you have the office spaces. And if you have a look at the flooring of this this backside, you will see that these are the granite panels that I showed you before. So initially this was wall cladding, but here it was transformed into a flooring. I haven't mentioned yet that the granite was that Jules Watts chose was finished as a flamed granite. It means that it has been heated with a plasma flame, and so that you have these that rugged surface that comes on the that appears, that is very pleasant to the touch, but also very good as an anti-slippery system. The granite was also coming from two different quarries in Italy. So you have these two varieties of gray, which is also very pleasant to look at. But what is probably worth mentioning here is that we had a whole lot of different dimensions for the plates that had been used to clad the walls. And we had to go through a painstaking, let's say, operation of putting these together according to the different thicknesses of the slabs, because we realized there were different thicknesses. So we created these zones in function of the thicknesses, designed a pattern for each of these zones, and then the very skilled artisan who put the floor in place could just work with uniform thicknesses, which made the work far more easy than it had been otherwise, even if it was still complicated. So another project that I'd like to show is one in which Valérie Vermandel, who will act as a respondent to this session, she knows it far better than I do, as she was the commissioner for this project for the company Whitewood, who bought over this structure. So what you see here are building or images of the construction site of this headquarters of Philips Belgium in the late 1960s. This is a view from shortly after the opening. So you have to imagine this is a huge tower block in the Brussels city center. It was, let's say, on the ground floor. It was a shop for the Philips electric goods, but the upper part of the building was obviously all offices for Philips employees. Now, Whitewood is really developing this into modern office space. What it did was to try and maintain as much as possible of the initial building in the heavy refurbishment that they conducted to make the building up to date. And Rotor assisted Whitewood in trying to, on the one hand, give a new purpose to all the materials that were extracted from the building and that couldn't reintegrate the renovation project, and on the other hand, identify second-hand building materials that could re-enter the renovated project as well. So what you see here is the extraction of some of the gigantic rusticated solid stone elements that were, as you see here, that were decorating the base of the structure. This is old Belgian blue limestone. But the rusticated surface was very skillfully done in the late 1960s, and it would have been a pity to lose that. So for those slabs that needed to go, but for which there might have been a new applications, there was carefully dismantled, stored, and then taken away to our warehouses. What you will see here is yeah. What you see here is the way in which this crane operator is doing the dismantling, and you see how the crane has been protected with these that kind of rubber glove, so as not to damage the stones. You will see also that the procedure is letting the stones fall on a bed of sand, so as to avoid them breaking or getting damaged. I will increase the speed a little bit so that nicely without here you see again the stones on storage at Rotor, and then for a specific application of which I will show you the plan that was kindly sent over by Valérie earlier today. You see that the slabs are being cut in their thicknesses, so to obtain the right thickness for its application. So obviously, therefore, it's at a traditional stone operator or with a stone operator that was collaborated, was used to work with freshly quarried blocks, and in this case worked with these almost 50 years old slabs. Here you see this is a plan of the bike racks that are part of the project, and you see that the interiors of that bike rack is completely lined with these newly redimensioned stone slabs. It gives you an idea of what this is going to look like. There was another challenge. So I talked about the reintegration of elements that were not quarried or urban mined on the site, but that the commissioner wanted to integrate in the project. That was let's say the surface of the ground floor. We've been looking at potentially fitting materials for that ground floor. And we ended up at a reseller of secondhand natural stone, which is called Maris, close to Brussels. And they had dismantled this gigantic square in Bruges, made out of bush-hammered, also Belgian limestone. That had been dismantled in 2017. And so eventually, together in collaboration with the architects, a design was found that was mimicking the original pattern, as you see on the top right of this image. This is an original interior image of the lobby of the building. So the idea was to put a new floor that is made out of secondhand stone that would re-evocate that original pattern. And it ended up as a combination of the bush-hammered originals with the recut, as the slabs from Bruges were too thick. They were cut in two, and then you had the flat surfaces that is used in between the bush-hammered lines. You will understand it better when you will see it. Yeah. So here at the bottom you see the bush-hammered lines, and then the let's say the freshly cut surfaces that are forming the surfaces in between. The same view here with the detail on one stone that has not been mortared, that is giving access to technical equipment under the floor. Yeah, and for the same project, that famous octagonal bichrome granite from the bank building was also used. So you have to imagine that this floor, we dismantled it somewhere in 2014, and now eventually it has found an application in the central Brussels something like 8 years later, but we're super happy that it comes into being. These are the first images I see of it, and I'm thrilled. I will go quickly through this. This is another a very different example of extraction as well. It's a building that is a magnificent, a beautiful building that unfortunately will be razed. It's a scandal that is it will happen, but we extracted from it only the window sills, which are made out of two types of marble. This is let's say North French stone called Grand Antique du Nord, and the other version, which you see here, is the Bleu Belge. These are both, let's say, Belgian, so-called Belgian marbles that are now completely exhausted. So you will not find them anymore. We were talking about stone as being an inexhaustible material. You have to know that Belgium is famed for its pitch black marbles. This is a version that is not completely black, so they call it blue in French, or in stone quarry, let's say, jargon. But then the funny thing is that marble, when it was almost formed, was like transformed by some motions in the probably millions of years ago, motions in the layers. And then you had that calcite that was pouring in, forming these beautiful veins. So it is a totally unique marble, very typically Belgian, used a lot in Art Deco times, and now completely disappeared. So this is geological heritage, and whenever we see this, our hearts beat faster. Another example of a very beautiful Carrara marble that we dismantled in the Brussels railway station, the North railway station. It's a marble from, so it's a project from the 1970s. Look at the nice detail of that rounded connection between the floor and the walls. When we submitted these marble to a good friend geologist who is like the Belgian authority on stone identification, he said like, okay, this is obviously a Carrara marble. There's of one specific variety from Carrara, which is called Calacata or Arabescato. And it's of an amazing quality. So he was completely thrilled when we showed these images of the dismantling. It's a marble that we had such gigantic quantities of available that it took us a while to sell it all, but it has all gone. So people love this. We bought a machine that allowed us to grind the edges of these marble slabs once you dismantle them. So, and that is something that we now routinely do when we dismantle marbles like these. That is we try and get a perfect quality for the edges of it, so that you can put it with almost invisible mortar joints. And then we recommend obviously to repolish the surface, and then you get something that is indistinguishable from a new marble floor. One of the nicest application of that marble was in a facade, a very surprising project of which I don't have very good pictures, but at least this gives you an idea. It's a recent project by an architect called Guillaume Socal. It's his own house or apartment. It's a penthouse apartment on the Boulevard Jasper in Brussels. Here, two detailed views. Again, the images, these are actually, let's say, screenshots from a very nice movie that was made out of it that you will find, obviously, without any trouble on the internet if you look for it. Yeah, and then to finish off, just again, a detail of another dismantling project that immediately shows you the challenges of dismantling elements like that. This is a lobby, a typical lobby of the Brussels European district, also Carrara marble. when we do dismantling tests, which is something we routinely do during inventories as we conduct them or surveys, is that we see how easy it is to extract these slabs. And in this case, it was like a combination of a good and a bad surprise. The good surprise was that as it should be done, the marble is placed on plaster, so not to damage the slabs, but unfortunately the joints between the marble slabs were made out of cement. So the cement obviously doesn't come loose as easy as it should be. So eventually we had to cut through all these cement joints a little bit like they had to do in the former presentation, to be able to take the slabs away each after each other. The advantage was obviously that you had that continuous nature of these joints, and then we were able to salvage all of these slabs and to hold them to our site and resell them. But it gives you an idea of how tricky it can be and how much salvageability is dependent upon the specifics of the joinery. That's it. Thank you.
For your presentation, and thanks to Robert too. So we will expand this session to the discussion, and maybe I had a first question to all of you. That's regarding the window. You know, not so much the window as a building component, but the window as a time frame, because I understood that for all of you, it's really a common challenge. It's really to create this space. Also, Robert mentioned the storage issue, but really this time space that allows people with a wish for reuse to access the building, either to survey the building or either to already start proceeding in dismantling work. I mean, I'm aware that Robert has been struggling through time to start surveying the building in time, because before you were depending on scaffolding. Now with the drone, you can anticipate a little bit your process. Adam, you haven't found a drone-related solution to your question quite yet, but surprisingly enough, you, Valérie and Lionel, you managed to create this space for the Project Multi through probably a lot of discussion. Yes, and legwork, but yes. So if you could address this question of window in the project management.
What we find is that as soon as the client has vacant possession, they want to start the project. So salvaging is not really part of their sort of priority. And that's the reason why we have such a short window. It's very rarely that they're going to say, well, we get possession of the building in January, but we're not going to start the works until such and time. So therefore, spend as long as you want. It's such a time-critical process, the repurposing of a building, that they need to start from day one on the get-go. And that's the reason why we rarely get time. So the way that we found to be able to do the surveys, which are quite critical, has been a real game changer for us. So we're lucky in this conversation, I suppose. That as long as the client is educated, we've got a chance to get a proper head start. And the good clients recognise that understanding the building at the very early stages helps them with their design at stage 2, stage 3, which could save them money later on because they can make a more informed decision earlier in the project.
Mm-hmm. But there's still this threshold of ownership, as I understand. You wouldn't be able to release a drone on a building where if you don't have the client permission.
It's in their interest to allow us to do it. I mean, they're not the people that would stop us from flying the drone. It'd be the police, and the police are then influenced by the Civil Aviation Authority. As long as we've got a non-standard flight request in, it takes 20 days, and then we can fly the drone, and you can do that anywhere.
Independent from the client,
independent from the owner, yes, because you're not on their land. You're in front of their building, but not on their land. So we're lucky in that sense.
Yes, thank you.
And I'm probably going to take it to a whole other part of the discussion. So I'm representing an owner. So we have multiple buildings. And I think certainly when it comes to stone, for me, the window starts when we start to design. By that, I mean, I have an architect, I have a project, we know that we have materials. And from the start, they have to think, okay, what am I going to reuse? What am I not going to be reusing? The first part, and I think 1/3 of the multi-project is about stones from the site itself. And there we were quite able to say, okay, it's from the site. We need that time to actually dismantle and to put that in the planning. But you have to do it from design stage. Otherwise, difficult. But on the other hand, and that's where we had a lot of discussions also with Lionel, it's about when you start to design a project and you have more than 2 years permit waiting in Brussels, you have a design and you have stones. And you say, okay, I have found on the second-hand market these types of stone that interest me. As an owner, normally, I don't wish to take the risk of buying stones before having a permit. But if I want to have the lot that is interesting for my architects, I have to start in advance of financing and stock for a project that might never be built because I might never have the permit. And that's something that usually architects don't think about, but for us it's very important. And that's why with Rota we had a lot of discussions. For example, Lionel de Gelois, it was a whole deal for me. It's not a lot, it's maybe 25,000 euros that we bought the Gelois package. So I think quite a deal. But we did not have that in equity available at the time, as minimal as it might seem, because we're not used to it. So for us, the multi-exercise is also an exercise about, okay, how to rethink the way that we develop and which risks do we want to take, for example, of a WABUS, or which risks do we don't want to take for a lot where we say, okay, maybe in the future we might find a similar one. But that's a bit a slightly different approach, I think, compared to maybe architecture and contractor.
Yeah, I mean, Vitruvius, and we have two companies. We have a salvage company and a design company. The design company certainly has many of these issues, but the design company has a sort of privileged access to the salvage company's stock, and we have warehousing, so they can only have their sort of unique aesthetic due to that close relationship. Regarding the window of salvage, I mean, in my working experience, it's a sort of just-in-time thing. I mean, we're normally hearing about demolitions as they're happening, or maybe just some days before the starting. I think I can remember one occasion in 20 or 30 years where we got a phone call from an architect who said, this building's being gutted out. Would you like us to write a 1-week window in the program for salvage? And obviously we said yes, and it worked out extremely well. But that was one time in 30 years and I wish architects did think about salvage as a I think the finances of salvage, with the conversations that are happening here, that they're coming from, state the obvious, from very different angles. You're doing a super high level conservation work, which is, I'm sure, fairly expensive for the client, to dismantle these buildings, and another Lionel's talking about salvaging some materials at sort of, at a relatively low cost. So, yes, the subject's the same, but the economics we're coming at is utterly different. And I'm sitting somewhere sort of, probably nearer Lionel's side of things, but I think the economics of salvage is sometimes very difficult. Mm-hmm.
But beyond, unlighted client representative or building owner or architect, which device or framework could help you in your work in the future, which could be the incentive that you can put on the table to encourage, the architect or building owner to plan this window in their project management.
I'm not the best person to answer that question. Because I don't know what all the intricacies of it. But I mean, obviously, there's sort of carrots and sticks, and sort of one stick is you have things like landfill tax, or there may be some other taxes based on waste creation or sort of carbon emissions or something. This kind of things, and then there's carrots that could could be waived with either planning carrots, saying you can do this with certain conservation materials, or there could be other sort of through BREEAM, sort of other sort of credits, that can. But it's not my field of expertise.
I was going to say, from a project that both of us know about, I think it's a bit of a game at the moment. The architects are providing the information necessary to achieve planning, and then the demolition contractors are trying to find a solution that it doesn't involve committing themselves to actually doing the salvaging work. So they're looking at the angles within the process that they can actually exploit to not have to salvage. And until they place it upon the client and the architect to actually use a certain percentage of the materials from that building in the rebuild, it's going to be a game, and it's only going to be the interested clients, the educated clients that understand the benefits, or there's an expectation, like with most of the projects I've shown, where there's a need to actually dismantle and rebuild. Unless there's legislation on them to actually come up with an exact percentage that they take off the building and put back in the same building, it's going to be more of a game, I think, of avoidance.
Yeah. I think for me to answer that question from my perspective is how to incentivize us, the project owners, to work towards reuse. I think for me there are three aspects. Of course, you have policy, but what we see on the market today is that ourselves and our competitors are way before policy for the moment. So we are more competing against each other than kind of following policy. I think if we were following policy, we were 5 years back. So it's evolving, but in the Belgium situation, that's a bit the case. What is important, though, is when we look at valuation of buildings. So what is the value that actually reuse can bring? What is the impact CO2, LCA is really having an impact on the market. So not only have to say, okay, my building has a CO2 impact in production, so for heating and electricity, but also what is the embodied CO2 of my whole construction site. And of course, when you look at reuse and the impact of reuse compared to new materials, well, it's way lower than using new. So we know that if we are able to incorporate reuse within the framework of our building by definition will be more sustainable. And when we try to attract certainly big corporates who want to monitor their CO2 impact, we see that this is of real importance. So that's the first thing, that impact valuations, because it makes it possible for us to have better clients. On the other hand, and that's a very important thing for me, I saw some people looking strange when they saw the blue stone fall on the sand earlier on, but I have to be very clear about this. It was very difficult to salvage this because the blue stone was actually used as what we say a lost frame to pour the concrete in. So the whole thing was really stick together, and it was not easy to release. And I think that brings me to the second part of valuation, is what is the value of materials within a building. And to give value to material, well, you should be able to know what is its composition. But okay, for stone, that's quite obvious. But also, how is it possible to dismantle it to give it actually a value? And I think for us, what the tendency that we see on the more corporate market is really data, so BIM modeling, etc., really crucial, but also the idea of material passports. And in Belgium, we were pioneering with some others in the introduction of something called a madaster. And the madaster is a cadastre for materials, which means that for every material element that you put within a building, there is actually an ID card, and you actually know what is the composition, how was it connected together, and it is. And that's the funny part and the important for my investors. It's linked to the stock market. So I know actually the value of my materials. And for the moment, we're experimenting in which way this could influence our business models also from a reusability perspective, which we hope in the future will be more important than now.
Oh, yes. Thank you. Lionel, would you have an input on this question of time management within a project and the possibility to access site?
Yeah, well, I think we've had some elements of an answer regarding the integration of second-hand building materials in a new project. I would want to come back on the counterpart, what we call extraction, and the time frame there. Let's say from our experience, it is very difficult indeed, especially for the existing operators on the second-hand building market or the salvage markets to access a building site, a demolition site, or a transformation site just to come and salvage a few things. I think the example that Adam gave is eloquent in that. And let's say the solution that we found for this, it's like a little bit of a foot in the door, was to develop the idea of an audit, which is something that we can sell to building owners very easily and quickly, in the sense that it's a survey of the salvageable building elements in a building that can be done months before any work takes place. So it's something that can be it's a survey that can even be done when people are still working in the office spaces or whatever the building is used for. And it's an assessment of, let's say, based on all the experience we have of those elements that we deem are salvageable. It can even be pretty cheap. We have a solution that we call a quick scan, which is only costing like a couple of €1,000 for the building owner. So it's in terms of cost, it's rather negligible. But once you have that document, then as I said, it's the foot in the door of bringing the building owner to further commitments in terms of making the salvage of these elements possible. And it's definitely a document that is also highly appreciated, we know, by public authorities. And so if you're in a situation where you have a building owner who wants to profile himself or herself as a responsible and sustainable commissioner, then it's definitely it's starting to become a crucial document. So I just wanted to add that this quick audit or that survey is probably a useful element.
And just to add to Lionel, I totally agree. And I think on most of our buildings, Rotor is actually doing these. But certainly with the discovery of the bluestone, use it as a frame, we also do a few pre-demolition tests also before any construction works start, just to see, okay, is it going to be easily dismantleable, and what are the losses that we're going to have? Can we keep 50%, 60%, 70%? These tests on 1 square meter or 2 square meters are done in the building.
Mm-hmm. Absolutely. Well, I think we're heading towards the beginning of a solution. And actually with the student and Diploma 18, we've surveyed all the building that will be demolished this year in London. And so the students went diligently through the planning permission application packages. And I could imagine that maybe in the near future, hopefully, this quick audit should be part of the package for planning application. Could be joined, as the project proposal is being presented to the council, that this idea of a quick audit could join. That would allow, within this planning application approval, maybe this window where where Adam could also access this information, since it's public already. So, and then maybe if you allow me to transition to a very technical question, and then I will leave the floor to everyone to ask questions and contribute. It's really, we've seen through your work, the Project Multi, but also Adam, I'm pretty sure you've done that before, to actually convert a facade cladding, granite possibly, or stone component, into flooring, and it comes with a lot of challenges. And if you could lay out some of the difficulties that can come along when you're doing such a flipping exercise.
I can think of a building down at Blackfriars that was classic sort of 60s building with sort of strips of windows and strips of stone, and it was Westmoreland green stone, and actually has quite a good non-slip quality to it. And I can't remember how many hundreds of tons we took, but it was very, very considerable. That converted into flooring absolutely seamlessly. Just you didn't have to do a thing to it. You just put it on a pallet and sold it. End of story. Our clients tend not to be, big corporate snazzy jobs. They tend to be small self-builders, DIYers, small hospitality projects. These kind of clients that we have. I don't think our clients are particularly, how can I put it, sort of rigorous with, I think they're treating this material as more as a sort of, historic material, that's not going to have a stamp on it. But I think with granite, it's maybe a bit more challenging. But of course, you can sort of flame texture it, or you could put some cut lines on it for anti-slip or something like that. From my side of things, we're dealers rather than we don't get too sort of involved in the specifics of how the reinstallation happens. It does on the design side of things. But that's not my expertise. But I don't think it's particularly difficult. I think the building that Amara and I looked at, and we're talking about in Fleet Street, I think the granite is about 30 mil thick. I can't see any possible reason why that's not a perfectly good floor.
We might have a debate, finally. Disagreement.
So I'm the quite picky owner. So we do large scale developments. So 40, 50, 60,000 square meters. So when we place something, we need guarantees, because if I have to replace it and it doesn't work,
Sure. Yeah.
It's about a lot of money. So we actually are doing this funny exercise with water currently. So we after 6 months of reflecting on a batch, we finally bought the batch. So what was the issue? We're doing it also with granite. 40 millimeters now. Why we had first a batch of 34 millimeters, but from Belgian legislation, if you want to put it on a terrace, you need 36 millimeters. So we tried to pass it on, and we did the tests and everything, but it was refused. So we kind of transited to another batch, which was bigger, which is now allowed. Actually, it's bigger than 40. It's a stone that has to be cut. So now we ordered the batch. The quarry bought a special machine, which is still underway. So I hope they get the deadline. They have to cut it in two, and then we will be able to replace them. And now the question is, okay, the finishing was too sleek. So it's a public terrace, so it's different than someone at home. So you have to do also testing so that people with these facade elements that were not made to be walk on, you really have to see, okay, how are we now doing the finishing so that the people will not fall upon it? So these testings are going on. First of all, we thought, okay, we're going to use the backside, which is quite rough, but apparently too rough, says the authorities. So go with that. So now we're turning the stone again and seeing, okay, which kind of finishings can we do to be able to use it on a public terrace, which is highly regulated in Belgium.
Wow.
Something that we come across quite a lot is people say, oh, we've got a limestone building, we want to dismantle it and we want to use it as paving. In simple terms, limestones are a sedimentary stone, and therefore they can only be used in one orientation, and they're cut in the orientation for walling, not for flooring. So you can't use walling for flooring. Granites and marbles are more of a freestone, so you can use them in whatever orientation you want. So you're not so concerned about their use in a different orientation. It's more about its slip resistance. But it's a constant problem. People just think that stone can be used as you want in whatever orientation you want. But particularly with limestones and sandstones, we use the bed to maintain its structural integrity in whatever we're using it as a cornice or as an ashlar. So it's something to be mindful of if you're offered that opportunity.
Lionel, would you have an experience to share on this exercise?
No. I think in our case, obviously the reuse of a cladding as a floor is obviously let's say the application of the precaution principle, in the sense that obviously we wouldn't recommend so easily a reuse of a cladding stone as a cladding stone, in the sense that you need to have total control on the way it is affixed to the wall structure, to be sure that it would work. So apart from that, no, I totally agree with what has been said. Marble and granite have those advantages. I think we haven't encountered the case of the reuse of a limestone cladding, as those types of applications are maybe a little less frequent in Belgium and Brussels, but it's good to know that it generates potential troubles.
Can I just add one thing? I think you talked about downcycling, and I mean, I think the slide you showed was about sort of crushing valuable materials down, which obviously is a huge waste of value. I don't personally have a problem with sort of downcycling, as in using a material in a slightly sort of cheaper way or something. As long as the material is getting reused, it can come down a sort of, from a corporate bank headquarters, down to a sort of, regional hospitality, use, and then down into someone's sort of, country cottage or whatever. It's as long as it's sort of being reused. It doesn't. I think that's a sort of perfectly valid.
You're talking about downcycling into going down the social ladder.
Correct. Yeah, but then it can always come back up, because I think a lot of people think that salvage. I mean, certainly when we started, there's a very big difference between secondhand and vintage. There's a very big difference in marketing, and so you would be talking about the same thing, but it's a very interesting perception as to whether you're talking about something losing value or gaining value. And obviously at Vitruvius we try and up as much as possible, but you can be there's a joke in the antiques trade. You say you buy secondhand and you sell antique.
Yeah, well, to bounce on that, Adam, let's say we obviously need in some cases to embrace what we call the cascading principle, where you go down by steps in terms of the initial functional value of the element that you have. And that's the case when, for instance, you would transform an oak beam into oak planks. Which is a practice that in some cases we find, let's say, embraceable if necessary. But what happens when you crush something is like you take the oak beam and you make a particle board from it. That is the downcycling approach. So it's the go for the full entropy. And in that sense, all these crushing aggregate crushers for us are entropy machines, and they're in many cases harmful machines.
Absolutely.
So it's already 3:30 p.m.
Hello. Yeah, there you go. It's already 3:30 p.m. and I wanted to ask whether we should take a 10-minute break and then have a big Q&A session after the third session, or we have a couple of questions in the chat now.
Yes, I think are there some questions specifically for Lionel? No? Okay. Then maybe we can, I'm just conscious that we need to move on. So we'll postpone the question to the next panel. Thank you.
Great. Then see you all in 10 minutes.
Yes.